All right, folks, welcome to week 9. Hopefully, everybody had a good week. And we're going to dive now into database security. This topic is half theory, half practical. I don't even do the examples in class because I literally give you most of the commands and slides, so it's pretty straightforward. Mac users, of course, are going to find this a little more challenging because Macs. It's just wherever you see a command in the instructions that says .exe, take the .exe off, and then it'll probably be okay. So first thing I'm going to talk about is principles of database security. So when you have database security failure, in other words, when a database server is compromised, it usually ends up with one of the following results. A breach, which means the data was stolen. Data loss, which means the data was destroyed. Or, the worst case scenario where you get a 2-for-1 deal, where somebody steals your shit then trashes your house. Now, when database information loss is actually a really bad thing, period. Data loss. Even though you can completely ignore the fact that a lot of the big companies that have breaches get like no consequences whatsoever. Like the big Equifax leak in the States a couple of years ago, which was just amazing. Literally, the people that got into the system got people's social security numbers, their credit card information, all their data, everything. It was really bad, and they slap on the wrist. Yes.
Yeah, apparently this happened recently as well, or last 6 years ago. When I get home, my girlfriend got a notice that's pulled into her chess.com accounts. Yeah, it's happening all over the time.
Yeah, exactly. I mean, I got a notice a while back from Case.Live, which is a bank, French bank, and this happens to be the one that one of the furniture stores around the water uses for financing. So what did I get out of it? I got 10 years of free Equifax coverage. Yay, but somebody has all my information. So, they gave me the information to make sure nobody's opening accounts and nothing's ever happened, so it wasn't a big loss. All right, so what are some of the bad things that happen? Loss of intellectual property. Sometimes you'll have proprietary data stored in a database, and if it gets leaked, people can do things. Corporate image and reputation. Having to admit that, your security was inadequate can be really damaging depending on who you are. Apparently, the bigger you are, the less it hurts. But for some small companies, it can be pretty much the death of a company. Business continuity. Sometimes data loss can literally kill a company or at least cripple it until things are restored. So if they have, which is next week's topic, which is backups, let's say you don't have proper backup setups put in place and, somebody, I hate the word hack, but, does an intrusion on your system, gets a copy of your data and then deletes everything. And if your database actually is set up like configure software, like the place I worked at before I worked for the government, the primary database was literally used to configure people's software. And if that database went down, people couldn't run their software. So, yeah, we had a lot of redundancy on that system, to say the least. So if your clients can't get in and they can't conduct business, they could sue you right into the ground. Penalties for non-compliance. Again, back to Equifax, which I don't know how they got away with this and not getting in trouble. So after, I don't probably everybody in here is almost too young to remember a company called Enron. That was a big company in the US who cooked the books and faked a lot of the financial records. And after it was discovered that they were just a giant pyramid scheme, a bunch of new rules are put in place, such as Sarbanes-Oxley. That's for auditing purposes. There's PCI DSS. That's the set of rules that govern credit card transactions, the rules of how credit cards are processed. HIPAA for medical records in the US, and GDPR for our friends in Europe, which is the General Data Protection Regulations, which basically says, person's data is their data. You don't get to do things to it that they don't give you permissions to do it with. And each of these organizations can fine you. PCI is notorious for finding companies where they find out the company's not compliant, and you start getting fines and you start getting extra fees where credit card processing costs more because you're not secure. And then there's the cost of recovery and damage mitigation. Fixing your stuff, communicating with your customers, possibly losing some business over it. That all costs money. If everybody's sitting there twiddling their thumbs for a week, you're paying people salaries for a week and nothing's getting done. You're paying for your IT staff to recover the backups, potentially, rebuild entire servers as needed. It costs money. So now that I've talked about what bad things are, what are some of the common threats? So there's something called insider threats. Those are malicious employees. I don't know if anybody here has ever worked where when you're being let go, you never get to touch your computer again. For example, when I worked for Compaq/HP, when somebody was being let go, they never got to go back to their desk. Like they were walked into an office, they were said, "This is your last day. Your box will be at the front desk for security in about 5 minutes." And then somebody would go through their entire desk and just pack their stuff up. And it was sitting, literally by the time they walked from the board, the escorted at that point from there to there, their stuff was sitting at the front waiting for them. Malicious employees, or sometimes these are disgruntled employees, or they do the damage just before they quit. So sometimes it's negligence where somebody's not paying attention, haven't had enough coffee, doing some work on the production server at 4 a.m. I've never done that. And I've never had to restore from a backup because of that. I'm being sarcastic. Yes, I've done it, and I've had to restore from a backup. Sometimes you got, corporate spies and infiltrators. You don't really think about that so much with small companies, but big companies, it's a thing. Human error. The meat sack is always the weakest link. In any IT organization, the weakest link is always the people. Writing passwords on Post-it notes. We had to keep having a chat with someone at my old job about doing that, where she couldn't remember her password, so she stuck them to the side of her monitor on a Post-it note. No, she did it. She probably saw it in a movie, thought it was a great idea. The worst part was she was the receptionist, which meant she was the first computer anybody saw walking in the front door. It wasn't as much of an issue once the front door was always locked when they moved and the front door was always locked, but before that, not so great. So then she moved over to writing them down in a binder, which she kept in her drawer. Just a little more safe. But anyways, don't write passwords down. Injection attacks. Those are people that are attacking you from the outside, crafting form submissions on a website that magically make SQL run. If they know what kind of database engine you're running, what kind of database you're running in the back, there's all kinds of interesting things they can do to you. Your code has to handle that. Malware. We all know what malware is nowadays. Yep. If you're someone, I don't remember the passwords. You got a password card. It's the coolest. So you can get these little cards. Here's the we're going off on a tangent. So you can get these little cards you can print. They're randomly generated. You can tell it that there's letters and numbers and special characters on it. And then you get it laminated so it doesn't get wet and damaged. And then you cut it out, laminate it, put it in your wallet. And then if you need to remember your password, go, I got to log into my Brightspace account. It's A4 for 8 characters. So you start at 8-4 and you just type in the next 8 characters. You never learn your password. It's always a secure password. And when it's time to change, you just move over to one. Yeah, you can look up password cards. That's what we ended up doing with the receptionist. Okay. So all she had on her Post-it notes was like A15, which meant nothing to anybody looking at it unless they had her specially generated just for her password. Yep.
You see me do like password recognitions from W from a few months ago.
Which is don't change your passwords and don't make them too long because humans can't remember them.
No, this is to make them longer, but easier for humans to remember. So phrases over like passwords with like vowels switched out. So if you have like a sentence long password type.
The horse is black and it likes to run with a period.
Exactly.
is a more secure password than keyboard vomit.
Yeah, because a computer can, anything short, computer can guess, pass around time, something long. So that might be easier, you just, it was things like the civil.
The best part is you could actually put in like, I live at 123 some street. Period. Your I is capitalized, you got numbers, you got special characters, you got the number of digits required. I was born on March 7th. Period. They'll never guess it. Even if they know your birthday, they'll never think that you literally wrote down as I was born on March 7th. I played too much Genshin. Period.
Anyways, I have, an alphabet, I think the first two letters of the website I use. Convert that into words based off those two letters, then I assemble a specific number of controls. So I was looking at the URL and figure out if the answer is.
That works too. There's all kinds of tricks for mental passwords. Okay, so we were talking about malware. We all know what malware is. Viruses, data hostages, that kind of stuff. Blackmail. And then there's attack on backups. Sometimes the really clever ones don't go after your servers. They go after your backups. They'll steal a copy of your backups and you never even realize they're gone. Then someday all the data's on the internet for someone to enjoy. That's actually a really clever way to steal people's stuff. If you can get a copy of their backups, especially if they use a service like Iron Mountain, where it's gotten better now. Iron Mountain requires a lot more verification, but it used to be as long as you had an employee ID and you could prove that you worked there, they'd let you in. And you could get asked for a box of backups. That's changed. That happened once. Just one time. Actually, that happened once because somebody used that exact technique to steal movie film.
No, really?
Yes, because a lot of movie film are stored in Iron Mountains, like they're literally in their mines. Because a lot of their safe storage is in mines, abandoned mines in the US, because they can, temperature control, humidity control, vaults. And the person showed up with a badge from the studio and said, "Hey, I'm here to pick up the prints for this movie." Have a box. They changed the rules on how that works after that. That's what triggered it. Oh, yeah. No, Iron Mountain started as a secure storage service.
That makes more sense based on.
Are they also the cheapest source to shred hard drives? Yeah, and they just put the hard drives right in the shredder. You're and there's like metal confess. Okay, so when you're securing the database, there is multiple steps to securing a database. Step 1, physical access restrictions. Don't let them touch it. That's what it is. Administrative and network access, user accounts, and service isolation. Okay, so physical security. Database servers should be held in a secure environment. Physical access should be restricted to the bare minimum number of users. For example, at SSC, each data center has 4 employees that are allowed to touch the servers. 1 for each shift. I think it's more than 4, but it's basically the F4 per given work week. So, the same thing with AWS and Microsoft Azure and all their data centers. The actual servers are physically locked into the racks. You cannot touch them unless you have the appropriate number of permissions. And very few people can actually, put their thumbprint on the little unlock it. Doors should be locked. Have a key card with a pass key. So only people that are allowed to come in, allowed to tap. Who's accessing the server room should be logged. If you're using the tapping thing, it's easy because you have logs from the taps. If you just happen to be a, tiny little mom and pop shop, there should be a camera that takes a picture every time the door opens, or you have a written log. That one's a little sketch. Because whoever has the key could decide not to put a log entry that day. One of the big perks of running a database in a cloud environment. You don't have to worry about physical security. It's not your problem. It's somebody else's problem. And companies like Amazon and Microsoft and Rackspace and Oracle really, really care about their reputation of their data centers. So they will do a very, very good job not letting anybody touch your machines physically. Because realistically, if somebody has physical access to the keyboard, it's not going to take very much to get past the server security at that point. Just saying. That's the true weakest link. Administrative security. So this is limiting who can do what to the database itself, not the server, but the database itself. So you want to limit how many super users there are. Normally you have one, and nobody knows its password. It's locked away somewhere in a vault somewhere, and nobody knows the super user password. Super user comes in, creates the first administrative user, and then that password is forgotten forever. If you have administrative accounts, those should be limited as much as possible, as in, if you're going to give someone administrative rights, you don't give them super user rights. You give them, hey, oh, you're administrating the WordPress site. Your user can only see the WordPress database and none of the other stuff. They can't create users. They can't delete users. They can't do any of that. Use modern security methods such as strong passwords, because, that's security. Even better, SSL keys. Instead of passwords, those are a file that's generated you have to have the private key so you can connect using the public key, and if the keys match, you're able to get in. That way there's never a password to remember, it's just a key. It's a file. A lot of cloud services allow you to encrypt the database. So even though it's going on their hard drives, on their hardware, the data is encrypted with a key that you own. That means that even if they pull off all the files that have to do with your database, they'll never see the contents because it's encrypted with a key they don't have. In theory, they can intercept the key, blah, 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 bad actor. But yeah, realistically, that's basically not going to happen. You should also limit where administrators can log in from. They should only be allowed to connect from either localhost, which means they're connecting from the actual machine itself, or they are connecting from a known IP subnet. You don't let them connect from anywhere in the world. That's a great way to let some guy in Russia run roughshod all over your data. Just saying. Okay, so now we've taken care of physical security. We've talked about the administrators. We should talk about the user security. User security involves restricting application accounts to the very minimum of accounts required. You don't want to have an account for every user in your company. That's just dumb. That being said, that's how Oracle used to work. Every person that accessed an Oracle system would have an Oracle database user. It's still kind of like that. It's just kind of gross. You want to restrict the number of interactive user accounts. So for example, back to my WordPress example. Most of you know what WordPress is. It's a CMS. You installed it. Congrats. You installed a big giant piece of bloatware. But yeah, it's a bloatware that makes making websites really easy. So WordPress has an interactive user. It's a user that can talk to the database. You want to not have 10 users that WordPress can use. You want to have one user that WordPress can use. And you want it to have the bare minimum number of permissions it needs. Because when you install WordPress, one of the first things it asks you is for your root account so that it can create the database for you and create all the tables for you. Then it creates a limited user that it uses after that, which often is asked, what do you want with the database user? What password do you want to give it? It's been a while since I installed WordPress, so, it is what it is. You also want to audit user accounts regularly. In other words, like once a month, you go through the list of users and you see if there's any users that you don't need anymore. Chuck them. If you are able to audit the user access regularly, have something that reads the logs and suddenly detect that, hey, user ABC connected from North Korea. That's not right. Right? Or user ABC connected from Argentina. We have no presence in Argentina, so who's connecting from Argentina? You want to log the access where they're coming from so that you can catch quickly. Now, some cool things is like, again, if you're going back to using the cloud-based databases, Amazon has something called CloudWatch, and basically you can say, I want to watch these kinds of things, and you can tell it, hey, for this database user, log all its access, and then if you notice something out of the ordinary, send out an alert. So then suddenly somebody's connecting from where they're not supposed to, you get an alert, and you can just kill that user right away, or just change the password or whatever. Assuming you got somebody watching the mailbox. But Okay, service isolation. Run your database behind a firewall. Running your database open to the internet, it might as well be walking around with your pants down on your ankles. Because everybody can see your stuff. And that's about as much security as you have. Databases are not super secure by default. They're not designed to be. They have security, and it's pretty good, but it's never been the number one priority of anybody who's ever created a database service. Because they assume, which we all know when you assume, that you should never assume that it's going to be run in a secure environment, which means it's going to be behind a firewall. You should probably separate your database server from your application server. So run them on two different pieces of hardware. In case one gets compromised, the other one might still be safe. So if the database server gets compromised, but they don't know the passwords, they could, if they were running all on the same server, you could go into the web root, go look at the WP config file, look at what users used to connect to the database, and congrats, you got a backup. About 30 seconds. That kind of thing. I'd never have your database connected to the internet directly. Just say no. You can. Amazon makes it really easy. Oracle makes it super easy. Sure, Azure makes it easy. I've never tried one in Azure, but just no. It's like literally you parked your car and then you put the keys on the hood and you walked away. It's there, it's out in the world, anybody can use it now, grab the keys and off they go with a brand new car. Well, if you're a student, it's not a new car, but with a new car to them. So never connect to the internet directly. All right, so now that we talked the theory of the whole security thing, we're going to talk about users and privileges. Okay, so database security works on the concept of privilege of least, the principle of least privilege. In other words, you give a user no permissions and only add on the ones they need. You don't start with all the permissions and take away permissions. You start with no permissions and add the ones they need. That way, it avoids a few small potential issues. As database servers get upgraded, often it adds new permissions and new permission types. And if you happen to have a user with a grant all permissions, it'll give it to those users too, even though they might not want to have it. On the other hand, when you create a user with bare minimum permissions, it won't add new permissions to those users. So let's just say example, the WordPress user. The WordPress user should have insert, update, delete, select. It may have alter and create. It might have drop because it might need those to installing plugins. But what it will not have is create database. It won't have drop database. It won't have grant. It won't have create user. It won't have permissions for those actions. That way, that WordPress user can't suddenly create a new user and give it to someone else. So you try to give the lowest possible access. Now, a good application also will have a user that only has insert, create, update, delete, and not even allow you to change table structure. Because, the less they can do, the better. So, type of privileges. You got admin privileges. So those are the rights that let you manage a server. It should be really limited and only granted to those who absolutely need it. That's the super users. Database privileges. Those are the privileges that say you can do something like drop database, truncate table, really bad things. Then you got object privileges such as tables, indexes, views, triggers, that kind of thing. You can set permissions on these things individually. Okay, so for user administration, user access can be controlled when the user is created. For example, you can set an IP address the user can log into the database server, and every server does this different. MySQL does it completely in the database, which towards the end of the slides, you'll see some create user commands that show you how that works. Postgres does it as a series of files. It's got a file with, the database name, a net mask, and, what kind of authentication that person uses. So we can restrict, for example, access for a given user to only be the corporate subnet. So they can only connect to the database server from 192.168.16 and only on that subnet. If they're not in that subnet, the database server would say, no, you're not allowed to talk to me, too bad. When a user is created, they do not have any privileges. So they're created blank. You then assign privileges after you create a user, it's blank, it's not allowed to do anything. Then you tell it, these are the things you're allowed to do on these database objects. So the create user syntax, and this is all MySQL specific or MariaDB specific as applicable. So the syntax for MySQL is create user, the username in quote marks, at the host in quote marks, identified by a password. The username is 16 characters long. The host can be an IP address, can be local host, could be a wildcard host name. If you just give it a % sign, it means it's going to be the person's allowed to connect from anywhere. If I go 192.168.1.%, that means they can connect from any machine on 192.168.1. So that'll be from any machine from 1 to 255. So the example at the bottom is create user Lisa at localhost, identified by password. That means that Lisa can connect from localhost using a password called password. This is one of the few things I will give credits to MySQL for. I really don't like how it does its security because it's just a pain to maintain. But by the same token, what's really cool is you can actually have users with the same username connecting from different hosts with different passwords. So for example, you got the local host user that might be a super user, but if they connect from 192.168.1.10, for example, they might have less privileges based on how you create their user. So you could actually have two Lisa users, but they have different privileges. If you want to change the password, it's alter user identified by their password. You'll notice it always has the username and the host. You have to provide both. Yeah. Yes. Yeah. I'm just using that as an example of how you change a person's password. Before MySQL 8, there was a different way. MySQL 5.7 and before had a different way of changing passwords. The good news is now that everybody's on 8, it's a moot point. Dropping a user, drop user if exists, you give it the user, so drop user Lisa at localhost. Gets rid of Lisa at localhost. If Lisa has a user for 192.168.1% sign, that user is not getting dropped. So you have to be diligent with your user management. Yeah. The username? Not really. You would have to drop the user to create a new one. And do all the permissions and everything that goes with it. No, you can rename a table, you can't rename the database. You can't rename a data, well, some servers let you, but some don't. No, the problem is with the user, there's also a series of tables with permissions in it. And if you rename one, you have to rename the other one at the same time, but then the permissions don't match and things break. So the rule is if you want to change a person's username, you drop the user and create a new one. Or create a new one, make sure it works, and then drop the old one. Okay, so we've created our user. Great. Now, we need to grant permissions. And so the terminology is you grant permission or you revoke permissions or privileges. And the privileges are all, select, insert, delete, update, create, alter, drop, and usage. So when you create a user, it gets a default permission of usage. In other words, this user is able to log into MySQL, but it's not even allowed to talk to any database, so the user will never work. So in MySQL specific, it's grant whatever you want to do. Now, MySQL 8 finally brought along the ability to do a per column permission. So you can actually tell the person, oh, they have read write to column A, B, C, but read only on D, E, F. Or they might not even be allowed to look at D, E, F. You can take away their select permissions on D, E, F. That's why you see columns in the square bracket. On the object, because you grant privileges per table in a given database, to a user, sometimes you'll want to put the identified by password, with grant option. So with grant option means that if you create a user, you can give them the ability to grant permissions to another user, but they'll only ever be allowed to give the permissions that they have. They'll never be able to go past what they have, but you can give them the rights to create users, but they can grant permissions, but they'll never be able to give them more permissions than they have themselves. Honestly, I don't see why that would ever need to be done, but it's a thing. So the example is grant all on dbmusic.star. So it's saying grant all privileges. So create, update, alter, draw, insert, delete on all the tables in a database called dbmusic. So dbmusic.star means all objects in dbmusic to the user, and then we're going identified by. Now the thing is that the user, depending on which version of MySQL you have, you might have to do the user at or not. Just look at the reference. So I provided a link to the reference on how to do it because that page is like pages and pages long and it talks about what different things do. So it's worth reading. Revoke. You revoke type of privilege on what to who. So revoke insert on dbmusic star from db user. That means the user can only update and delete, but he cannot add. Again, a link to the syntax reference. And if you want to take away everything from a person in one fell swoop, it's revoke all privileges, grant option. Be safe to make sure that they're not allowed to grant anything. So can't assume that that's good. From, in this case, it's Bob at %. So it's saying Bob at any host is not allowed to do anything anymore. And again, a link to the documentation. This is the documentation version 8. I think we're on version 8.4 or 8.5 now, but really that hasn't changed. So let's say you are connected and you want to see what a person can do. The command is called show grant. So far you guys remember last semester, show databases, show tables. For security in MySQL, we got something called show grants. So you go show grants for a user. In this case, it's show grants for Lisa at localhost, and it'll show you the permissions Lisa has on the local host. And it'll just show you a nice commented limited list of permissions on what objects. So flush. When you grant privileges or revoke privileges from someone, you have to flush the permissions data. Because what MySQL does is when it first starts up, it reads all the permissions and stores them in memory so that every time somebody does something, it doesn't need to ask the database, is Bob allowed to do this? Is Lisa allowed to do this? Is Frank allowed to do this? It just looks in the memory and goes, oh yeah, I remember Frank's not allowed to talk to the database today. So if you create a new user and you set new permissions or you take permissions away, you have to flush. And it's literally flush privileges. What it does, it tells MySQL, hey, all those permissions you remember from earlier, they no longer exist, reread them. So it flushes the toilet, fills it up nice and clean, it's ready to go. It's instant, like we're talking like milliseconds. 99% of users will never even notice it happened. Okay, so that is the end of the flush syntax. Like I said, every command you need for the lab that So Fraz canceled today, which is good. Because I told her, hey, he said, I got to cancel the lab. And I said, that's great because they haven't had the lecture and they kind of should have the lecture before they do this lab. So it worked out for you guys. Because the second half doesn't have that 1 week delay from installing and get your shit installed. That gives you a 1 week delay to do the work. So it kind of worked out that this first lab was canceled. So in the end, every command you need is there. Like I said, for the Mac users, it's going to be a little bit different. The good news is for this one, for the most part, it's all done in MySQL. So you don't need to worry about it. Next week stuff can be a little harder for the Mac users. This week, you just have to, connect using Data Grip or MySQL Workbench or, if you want to go hard mode command line and do the work. But yeah, that's everything you guys need for this. So any questions about the security? I mean, it's fairly straightforward concepts. There's create user, drop user, alter user, grant and revoke and flush. There's 6 commands. And if you're not sure what the syntax is you need, go look up the syntax. It's important at this stage in your careers that you learn how to read documentation. And the MySQL stuff isn't too bad. If I go back to let's go look at, no, the next one before that. There we go. Grant. So, like, that's the example they have at the top, which is just terrible. But they cover, how to grant. They have some simple examples on how to do it. And then they got some important things that you may, and the warnings are kind of things you might want to look at. But honestly, for most of the lab, the grant is all you're going to need. If the lab goes like it's supposed to, and I did try and it worked when I did it, but Murphy's Law would state that something changed from when I created the lab to when you guys are doing it. Some of the work is you create a new user and you connect as that user. So you're going to have like 2 connections going, see what the permissions are for that user. Like, hey, this user has these permissions. What can you do this? And yes or no, or what's the error message? As long as you don't get hung up, it's actually a fairly straightforward lab. Speaking as a teacher. But I've tried to make it straightforward and pretty clear. So, anybody have any questions before I call it a day for you guys? A nice short class. Like, I could just literally cover like most of the last semester in like 3 classes. But in fact, I'm not allowed to do that, so.
It's pretty clear. It's pretty similar. The ability stuff. It's just
Yeah, I mean, realistically, you're opening ports in a firewall, you're determining what kind of traffic's allowed to go through the firewall.
It's like a file stuff.
Concept-wise, yeah, there's actually just more permissions in database.
Yeah.
Like I've taught Linux years ago, and yeah, I know all about chmod. I used to know the octets off the top of my head. I used to know how to do the octet math. I used to be able to calculate the UMask without having to use a tool. But yeah, the UMask is interesting. It's subtractive per column. It's not 777 minus 666. It's 7 minus 6, 7 minus 6, 7 minus 6. So even though the number always, it'd still be the same, but that's just not how it works. So just saying, when you're trying to calculate UMasks, that's the surprise. All right. If there's nothing else, I am going to call it here and you guys can go chill.